So hi everyone, welcome back to my channel, and today we're going to learn double integral for type 1. Okay, actually for type 1 and type 2, it's just a little bit different, which type 1 we just have a constant, which for type 2 we have a little bit unknown over there. Okay, for this type 1 is quite easy compared for type 2 because type 2 play with the unknown, type 1 you just substitute back the value over here. So I will show to you guys some of the techniques that I use to solve this question, and I hope it's going to be useful for you guys. So yeah, let's go. So for the first question is this one. Okay, for the first question is this one. So they're going to give you integrate and also the value of s and y. Okay, the range of s and y. So this one is actually your s is between 0 and 2, and also your y is between 1 and also 2. Okay, so how are we going to do? It's very easy, so your dA, you need to remember your dA is equals to dx dy. If they given to you dx dy straight away, you don't need to change it. Okay, so for this question they give you a dA, so what you need to do, you just copy it back. Okay, just copy it back, and first thing you need to do is change your dA to ds and dy. Okay, so I'm going to write over here, so I'm going to have here s minus 3y squared, and then dA I change to ds and dy. Okay, and after that what I'm going to do is I'm going to follow the arrangement. So here I come with x first, only I going to see y, so I need to take my x first, and then only I take my y value. So my x value is 0 and 2, so I'm going to put here 0 and 2. My y is 1 and 2, here 1 and 2, so here going to be 1 and 2. Follow the arrangement. If here y first, okay, so I'm going to put y over here and s over here. Okay, so for double integral for type 1 or type 2, or maybe for triple integral type 1 and type 2, we're going to apply the Frobenius theorem. Okay, what is Frobenius theorem? Frobenius theorem is actually state that we can just integrate dy and dx. We can just interchange it. Okay, I can do it something like dy and dx, or ds and dy. You're going to get the same answer. That's how Frobenius theorem works. Okay, so yeah, for this question I'm going to use ds and ds dy. So after that, what I'm going to do, I'm going to do the first integration over here. Okay, so you respect to s. Okay, you integrate respect to s. So what you're going to do, your y going to be a constant. Okay, your y going to be a constant, so here I'm going to get 1 and 2. Okay, here I'm going to integrate, so integrate s, I'm going to get s squared over 2. Going to, when I integrate this one, I'm going to get 3s y squared. You're going to be 0 to dy. And then after that, what I'm going to do, I'm going to get, you just substitute. Okay, follow the arrangement, and then what you need to do is just, okay, just integrate it, and then you integrate it and then substitute. Okay, it's very easy. This one is just basic substitute. Okay, substitute. Okay, so this one is just a basic. Okay, so this one is just substitute. So here going to be 1 and 2. Here going to be 2 squared for 4 over 2, 2. So here going to be 6y squared. Okay, and then you need to minus with 0, 0, and going to be 0. Okay, so 0 squared 0, something times 0 going to be 0 again. So here is dy. So after that, what we're going to do, just integrate it. Okay, just integrate it. So what we're going to get is 2, going to get 2y, and then 6y squared, going to get 6y cubed over 3. Okay, and then going to get this one. Okay, so after that, what we're going to do, we're going to substitute the value. Okay, so here I can just cancel. Okay, just cancel 1 and 2 over here. So 2 times 2 we're going to get 4, and then minus with 2 times 1 power 3 going to get 2. Okay, and then minus with, oh no, 2 times with 2 power 3. So 2 power 3 is 8. 8 times 2 is 16. Okay, you're going to get 16. Okay, and then after that, 1 over here, so you're going to get 2 over here, and then 2 times 1 power 3, you're going to get 2 again. Okay, here going to be 0, you're going to be negative 12. Okay, and then for the second question, the question given is this one. Okay, so you need to know the first one is your S and the second one is your Y. Okay, if they didn't give you this kind of form, okay, this kind of thing, they're going to give you in this form. Okay, in the range. Okay, but this one is easier. Okay, so the question is 6 s squared y squared minus 5y whole 4 dA. Okay, so the first step we're going to do is just change your dA to ds and dy. Okay, ds and dy, you can just apply the Fubini's theorem over here and see which one is easier. Okay, for me, s and y is both also easier, so I just choose either one. Okay, so here, after that, what I'm going to do is follow my arrangement. So since the s come first, so I substitute the s value first. If y come first, then I substitute the y value first. Okay, so here going to be 0 and 3. Here going to be 0 and 1. Okay, my s value and y value over here. So after that, what I'm going to do, I just integrate it and substitute it. Okay, integrate it and substitute it. So since I want to integrate respect to s, so my y becomes the constant. Okay, my y becomes constant, so I'm going to integrate. So s squared integrate going to get as 3y squared over 3, and then minus y as minus 5 as y power 4 0 3 dy, and then I just substitute it. So I just substitute it, going to get here going to cut here 2. So 3 power 3 27. Okay, 3 power 3 27, and then times 2 going to get about 54. So 54 y squared, and then minus with 5. My s 3 times 5 going to get 15 y power 4, and then minus with 0 and 0, so going to be 0 over here, so I don't need to write it back. Okay, so after that I'm going to do integration again. Okay, you're going to do integration again, so I'm going to integrate it again. So 54 y whole 4, here going to be 3, and then minus with 15 y power 5 over 5, and then 0 and 1 over here. Okay, so what I'm going to do is just need to do the same thing. You need to substitute it back and then get the answer over here. Okay guys, so that's the answer for the second question. So we move on for the last question over here. So for the third question, okay, yeah, the question is a little bit complex, but don't worry guys, the method used is just the same like how we used just now. Okay, so yeah, I'm just going to copy the question first. Okay, so we are going to be s y squared s squared plus 1. Maybe some of you guys are going to ask me, why are you going to apply the Fubini's theorem? Why are we going to apply the Fubini's theorem? So for this question, I'm going to show to you guys how we're going to apply the Fubini's theorem. Okay, let's say some of you guys want to start with the dy and ds first, okay? Or maybe ds and dy. Okay, you can choose either one. Okay, so how are we going to apply the Fubini's theorem? You need to see the question first. You see the question, you need to determine either this this question is better to integrate respect to y first, or better to integrate respect to x. So you need to determine. But for me, what's wrong with me? Okay, but for me, it's better to integrate respect to x first. Why? When I times here 2 and half over here, I'm going to get something like ln. Okay, and yeah, it's easier for me to like substitute ln, since here is 0, since here is 1, maybe might get 1, right? Okay, So yeah, I think it's easier for me to respect to x first. Okay, let me show to you guys. Okay, so I'm going to copy it back, copy it again and again. Okay, I'm going to change it. Okay, here as y square over s squared plus 1. So I'm going to, like I said, I'm going to integrate respect to x first. So I'm going to put the x value in front. Okay, in front 0, 1, and the y value after that negative 3 and 3. So yeah, since like I said, it's easier for me to integrate respect to x first. So yeah, I'm going to just put it here 2.5 at the back. Okay, so when I integrate respect to s, what I'm going to get is going to get ln. Ln, just copy the I'm going to just copy the denominator, okay? And then what I'm going to do is my y square is a constant, so I just put it here, okay? My y square, okay? It doesn't matter. You want to put in front or behind, yeah, it's just the same, okay? It's going to be 0 and 1. So after that, what I'm going to do, I'm going to, yeah, I'm going to copy here and then substitute here. So ln 1 square plus 1 is going to be ln 2 y square. Okay, this one is a two different thing. Okay, why not I put the y square in front? Okay, so y square is going to be ln 2. So ln 0 square plus 1, so going to be ln 1, and you know the ln 1 is 0, so I won't write it here. Actually here is minus. Okay, sorry guys. So going to be like this only, so respect to dy after that. So what I'm going to do is going to respect to integrate respect to y after that. Okay, so oh my god, I think I need a new marker pen. Okay, oh my god, okay, it's okay. So okay, I'm just going to integrate respect to x. So here 1/2, and then just going to integrate y cubed over 3. And then ln 2, I'm going to put behind ln 2. Okay, here going to be negative 3 and 3. So after that, I'm going to do here ln 2. Okay, ln 3. So here 3 square, 3 cube. 3 cube is going to be 27 over 3. And after that, I can just bring this 3 out actually. Oh my god, I missed it. Okay, so after that, minus with negative 3 power 3 going to be negative 27. Okay, then you guys can just get the answer. So yeah guys, that's all for the double integral type 1. And yeah, for the next video I'm going to teach you double integral types 2. And I hope you guys enjoy it. I hope the method that I use is yeah, useful for you guys. And yeah, see you guys in the next video. Bye bye.